Hello everyone, myself Bhavana Rani. This is my teammates Bindu, Dibeshri, Mansa and Sinchana Pooja. Topic is ROC and AUC versus accuracy. Uh, ROC versus AUC, understanding the model performance. A deep dive uh, into received operating characteristics, ROC and curved and area under the curve, AUC and matrix are essential tools for the evaluating classification models. The challenge of the classification accuracy. Uh, Simple classification accuracy can be misleaded, and especially in the data sets with the imbalanced classes. In imbalanced, it fails to different type of errors, imbalanced data and error blindness and threshold dependence. In the imbalanced data, the model predicting 95% negative outcomes correctly might have to pure performance and the crucial 5% positive classes. And in error blindness, accuracy treats false positives and false negative equalities. In threshold dependence, accuracy is bound to single decision threshold and affairing and the incomplete pictures of the models and potential across different settings. Next will be continued by Bindu.
Thank you, Bhavna. Next coming to introducing the ROC curve visualizing performances. The ROC curve is a graphical representation that shows how well a model can distinguishes between two clauses, positive and negative, as the decision threshold changes. It plots and two important metrics. First one is true positive rate, TPR, also known as sensitivity or recall. TPR is equal to true positive divided by true positive plus false negative. Coming to next, false positive rate FPR, calculated as one specificity. FPR is equal to false positive divided by false positive plus true negative. The ROC curve is drawn by plotting an TPR y-axis against the FPR x-axis at different classification thresholds. Next, coming to next slide. How to interrupt an ROC curve. The shape and position of the ROC curve provides an insights into a model predictive power. First, ideal performances. The curve that hugs the top left corner, TPR is equal to 1, FPR is equal to 0, indicates a perfect classification. Such a model correctly classifies all positive and negative. Next, random guessing. The diagonal line from 0, 0 to 1, 1 represents a random model with non-predictive availability like flip a coin. The area under this line, AUC, is 0.5. Better versus worse model. The curve above diagonals represented a model better than random. The feature above the diagonal, the better the model performances. The curve below the diagonal indicates model performing a worse than random. Next, we'll continue by Sinchana.
Coming to the area under the curve AUC, a single matrix. AUC is a single numerical value that summarizes the overall performance of the model across all the plausible classification thresholders. First one we have, it represents the probability that a randomly chosen positive instance will be ranked highly, where assigned a higher score than a randomly chosen negative instance. So next one we have AUC values which ranges from 0 to 1. Here we have AUC accuracy as 1.0, which it is a perfect classifier. All positive examples are ranked above all negative examples. Next one we have AUC, which is 0.5 value, and which is equivalent to random guessing, no discriminative ability. Next, coming to why AUC is preferred over simple accuracy. So AUC provides a more robust evaluation of a model's inherent ability to discriminate between the classes independence of threshold selections. First one we have threshold invariance, scale invariance, and imbalanced robustness. So coming to the threshold invariance, we have AUC evaluates model performance, which across all the thresholders, unlike accuracy, which only gives a snapshot at a single points. So scale invariance, we have AUC measures how well predictions are ranked, not by their absolute values, by providing consistency even if prediction scores are poorly calibrated. So imbalanced robustness, it is minimally affected by a class imbalances, offering a reliable metric even when one class heavily outweighs the other. So coming to the limitation and nuance of ROC and AUC, while powerful, AUC and ROC are not universal solutions. They have specific contexts where their utility is diminished. So coming to the focus on ranking, AUC only cares about the rank order of predictions, not the magnitude of scores. It won't tell you if your model is well calibrated. Power for extreme imbalance. In case of extreme class imbalances, for example, we have ratio of 1 is to 1000. The precision recall curve, which is PRC, and its AUC are generally more informative. Here, coming to the ignores class probability, AUC is a measure of separatability, but it does not account for the pure probabilities of the classes, which may be crucial for decision making. No cost insight, it treats all false positive equally and all false negatives equally, ignoring the often different economic or ethical cost associated with the specific errors. Further will be continued by Divyashri.
Let's apply the ROC and AUC to the matrices that are widely used across the various fields to ensure the model reliability. Now coming to the medical diagnosis, that is evaluating and sensitivity and specificity of a model predicting a rare diseases and high AUC accuracy area under curve ensures the model performance reliability regardless of the cutoff for a diagnosis. A reliable disease detection with a rare cases. Final fraud detection in a system where and fraud very rare, an AUC helps to determine if the model can effectively rank the fraudulent transactions higher than the legitimate ones. That is used for the detecting of the frauds. Next, predictive maintenance as accessing the ability of a model to predict an equipment failure before it happens when ROC that is helps to select a threshold that balances an unnecessary maintenance that is false positive and a catastrophic failure that is a false negative that balances a false positive and the false negative with an preventment of the equipment failure. Choosing of the right metric of the problem. Selecting an evaluation matrix must align with the specific goals and the cost structure of an applications that is with the high business priority, threshold flexibility, and the low business priority and the threshold performance. Now, picking up of a matrix is based on a threshold needs that is a accuracy, AUC, F1 score, and the precision and the F1 score. Accuracy, which is simply correctness of the measure. AUC works well with a threshold tuning. F1 score balances a precision and recall and good for a rare positive cases, and the precision PR AUC good for the rare positive cases. Key takeaways and the next steps. Now coming to the key takeaways and the next steps, that is the ROC and AUC are the cornerstones of the classification model evaluations which offering insights behind a simple accuracy. The ROC, the visualizations which shows the trades-off between positive rate that is the record and the false positive rate at a different thresholds. That's a visual diagnostic tool. Now the visual trades-off between the recall and the false positives. The summary of the AUC is a single threshold independent matrix of overall discriminative performances. Higher is better up to the 1.0. Let us give one score on the model discriminative power. This higher is equals to better. Beyond accuracy, they always prefer AUC over accuracy, especially when with a class imbalance to the truly understood your model capability. Uses a AUC accuracy for an imbalanced dataset for a true judge performances. Now coming to the code. That is the importing of the necessary libraries, that is the pandas and the numpy, and the using for the numbers and the pandas for an essential for an handling of the data. And from an SQL and datasets we are importing an data and the matplot for visualizing the data, and from SQL and matrices we are importing accuracy, precision, F1 score, and the confusion matrix and the ROC curve from the SQL and tree classifier, which prints the decision tree classifier. Now coming to the training of the data, that is taking of the data set with the n samples with the 5000 and the features with a 10 features, number of the features, and informative features with a 4, and the redundant features with a 2, and the clusters, that is number of clusters per classes is equals to 1, and the weights, that is an imbalanced ratios, that is a 98% versus a 2%, and the flip, that is equals to 4, and the random state, that is equals to 42, that is equals to 42. Now coming to the df is equals to pd.data frame, that is a x columns with the features and for in the range of the 1 in comma 11, and the target variable is equals to y. So now coming to the loading of the data sets, that is an imbalanced data set .csv, and the printing of the imbalanced data set, data is saved as an imbalanced data set. Now coming to the training data, that is training data is 70% and testing data is 20%, with a test size of the 0.3, and the model with a decision tree classifier, and the random numbers 42. The model fit is equals to x underscore train and the y underscore train. The y prediction is equals to model dot predict, that is x test, and the y predict props with the model predict probability, that is x test, and the printing of the testing on the accuracy on the test data and the prediction of the y, and the precision score and the recall and the F1 score, and ROC and the confusion matrix. Now coming to the printing of a model evaluation with the accuracy, precision, F1 score and ROC. Now coming to the plotting of the confusion matrix and the predicted versus actual value for the showing of the confusion matrix, and that is a false positive rate, true positive rate, and the threshold with ROC curve with a y test data and a y predictable probability. Now coming to the plotting of the figure size, that is 6,5, and plotting of the ROC and AUC curve, and the plotting of the x variable, that is a true positive rate and a false positive rate with a y label of the plotting of the ROC curve, and the plot dot show, which visualizes the graph. Now coming to the output code, the data set is saved as an imbalanced data set, and the model evaluation is accuracy is 0.99, which is an fully accurate, and the predictions is 0.8, the precision is 0.883, and the recall is 0.667, the F1 score is 0.740, and the ROC and AUC curve is 0.830, and here is the confusion matrix, and the ROC and the AUC curve with the true positive rate as an x-axis and the false positive rate as an y-axis. The ROC and AUC curve is equals to 0.83 as an accuracy. Here is a small assignment which is guided by our coordinator Akshata ma'am. Thank you.